having one keynote speaker, Dr. Anton van der Vegt from the University of Queensland, Australia. And we will also be having two parallel sessions, awarding sessions, and closing ceremony to mark the end of InCITE 2020. Proceeding to the next agenda, in a brief moment, we will have the third and last keynote session by Dr. Anton van der Vegt. Before we going on to the next keynote session, please let me introduce our moderator, Assistant Professor Dr. Jimmy. Mr. Jimmy is the chair of the third biannual International Conference on Informatics, Technology, and Engineering. Without further ado, I would like to hand over the session to Mr. Jimmy.
Hey everyone, thanks Yamima for this. So welcome everyone. So this is the last day, and today we will have our last keynote speech from Dr. Anton. Thank you very much, Anton, and welcome to our conference here in Indonesia. And it is a real privilege to get Anton in here. He was one of my colleagues. We did a PhD together, and we graduated right about the same time. So welcome. I really appreciate for you to come here. So let me introduce briefly about Anton. So he finished his PhD in information retrieval from the UQ, and he is a sponsored student by CSIRO. So CSIRO is like the a big research organization in Australia. I think it's either the biggest or the only research organization.
Public one, yes.
The only public in Australia. So his research is in terms of time and knowledge constraint in the ability of clinicians like doctors to make high quality clinical decisions. So that's a bit surprising for us in general public that even doctors actually go and find information from Google in the internet, right? So I thought it's only us, the general public, that do that. So he's working on that one. He's working to help people like the doctors to make decisions based on information in the internet. I think that's quite long, so I will let Anton to share what he's currently doing. And he's been working in a really, really interesting topic called Empower. Thank you. I'll let you take the stage, Anton.
Thanks, Jimmy. I appreciate it. I'll just share my screen if that's okay. Okay. Oops. Yep. Okay, you can see that now, can you?
Yep. Good. Perfect.
Okay, great. Well, thank you very much, everybody. Great to see all those faces out there. This morning, I'd like to talk to you a bit about a piece of applied research that we've done. So this is very much a case study, and it's showing you a system that we've built for Queensland Health. So we've worked in a group that's a joint venture between the University of Queensland and Queensland Health. And I'll tell you a little bit more in the actual presentation about Queensland Health itself and the work that we've done. And I'm going to show you an application that we've built for them. Okay, so I'll take you over a couple of items. There's not too many. Opportunity and challenge that we saw there. The solution itself, which is called Quiet, and I'll explain why it's called that in a moment. And then I'm going to walk you through that application and show you a little bit about the future work we're going to do with it as well. Okay, before we go on, I need to explain something that's really integral to the discussion that we're going to have today. And that's all around what an electronic medical record system is. So briefly, an electronic medical record system consists of two main parts. There's the patient administration part, which is sort of this part over here. And that's the sort of thing that allows the administration to work. So they know that where the patients are, how many beds they've got, where the beds, which wards they're in, where the nurses are, all of that kind of thing. We're not that interested in the patient administration aspects of the system, of an electronic medical record system, but we're very interested in this, the clinical information system. And that controls all of the, when a patient kicks off and they go to the hospital, they're going to walk straight in and get entered into the system, and everything that happens to them in the hospital is going to get recorded in one of these electronic medical record systems. So everything from which bed they're in to vital signs that might be collected. The clinicians may make clinical notes. on the data about the patient inside the system, and they might get lab results, they might conduct tests, etc., etc. So I'm going to be talking a lot about an electronic medical record system today, because that's the basis of our program that we've created. Okay, well, what can we use this EMR data for? So obviously they collect all of this data, and typically they're going to use it to just whilst the patient is actually there in the hospital to make sure, you know, to work with the care that's provided to the patient all the way through until the patient leaves the hospital. But we're actually really interested in all of that data for many more reasons than just the operational aspects. And here are a few of them. You know, for example, we might want to identify patients at risk. So they might be in the hospital, but they might acquire infections within the hospital. And obviously we all know about COVID-19 and people actually acquiring COVID-19 within the hospital. But if you could try to predict when that, if that's going to happen for patients, then that's all about assessing the risk and measuring those and trying to make those predictions. And one of the other key ones is around deterioration. So that's when a patient is actually is at risk of getting much, much sicker very quickly and potentially having, say, a cardiac arrest or dying. You also might want to predict the outcome. So how long the person's going to stay in hospital for. That's really important for planning for the hospital. You know, how many beds they've got, how many patients you're going to have in the hospital. And then also things like 30-day mortality. So is the person going to die within 30 days or are they going to get readmitted back into the hospital? These are all classic sort of predictions that you're trying to make so that you can run your hospital better and provide a better level of care. And then there's all of these other kinds of things where you're trying to improve the clinical workflows. So things like better treatment options. You might do A/B testing on different drugs that are being used for specific conditions, or better care procedures. Because in one hospital, the doctors are doing certain practices, but in another hospital for the same condition, they're doing different practices, and you want to evaluate those. For also selecting clinical trial patients and things like just normal clinical decision support, where you're giving clinicians more information so that they can make better decisions around diagnostics, etc. Oops. Okay, so a little bit of background. Queensland Health, we have the largest and only statewide electronic medical record system across Australia. So what I mean by the largest is we're servicing all of the patients across Queensland, which is many, many millions. And the database itself, to give you some idea, consists of 6,000 tables and 100,000 fields of data. So if you're used to using databases and conducting SQL queries, for example, if you're an IT student, then you'd realize that this is not any kind of small database. This is a very big database. And not only that, within tables, some of those tables have billions and billions of records. So the potential for the reuse of this data to improve clinical outcomes through things like providing dashboards or reports or research extracts is immense, but obviously it's not going to be easy. So what are the challenges? Well, mostly it's around these two constraint areas, database complexity and the limited expertise. So in terms of database complexity, it's really impossible for non-technical staff, so clinicians and researchers, to be able to go in and get their own data out of this database. As you can imagine, with 6,000 tables, 100,000 fields, trying to access that data is just completely impossible for people who don't understand the structure of it. And even identification of the desired data they want is extremely slow. It takes many, many days and lots of iterations. So for example, if you want the patient's heart rate, for example, you think, well, that's pretty easy. I should be able to find that. Well, the heart rate might be collected many, many times throughout the patient journey in many different places. And it may be put into many different tables within the database itself. So even just finding the right heart rate that you're looking for is a very difficult task. And even the technical experts find this very difficult. They might know the EMR quite well, but trying to track down the right field is very difficult. And they have special programs that actually allow them to look at the data entry screen and then track a particular field all the way back to the database itself. So as you can imagine, it's a very slow process. And then every time you have a project which generates data, a data product, so you have a dashboard or you want to make a report or you want to get a data extract out, it often always starts all over again. So although a person has worked with a technical expert and together they've derived what data they want, where they get the data from, but then the next person comes along, they might get a different expert, and all of that knowledge is kind of lost and they have to start all over again. And finally, the provenance, so where the data comes from, is also very difficult to track. So if a clinician's looking at a dashboard that has all of this information on it that they're using, they might say, oh, I wonder where that heart rate value came from. It's very difficult to actually track that heart rate all the way back through to a particular SQL query and then back to the field in the database and back to an actual definition, a clinical definition of what they're actually looking at. Okay, so I want to introduce you to a solution that we provided for Queensland Health called QITE. It's called QITE because it's Queensland Integrated Element Tracker. It wasn't my naming. I can't say I love the name myself, and it's certainly not a QITE application. It is just an application, but it's one of those acronyms that people like. What is QITE? Okay, it's a straightforward web application, okay, that lots of you will be familiar with using all the time. What's the purpose of QITE? Well, it's to facilitate the creation of data sets for researchers and clinicians primarily, and it's based on the structured data in the EMR. So by structured data, I mean you know what's going to be in that data field. If you've got patient age as a field, then I'm expecting a number with their age in it. And that's as opposed to unstructured data, which are things like clinical notes, where people can just write whatever they like into that field. But in this particular application, we're only interested in the structured data. And we want people to be able to do that without actually having to have knowledge of the underlying EMR data structure. Okay, so I want to break that down a little bit further. So just to be clear, the primary goal is that a non-technical person, i.e. a researcher or clinician, will be able to define the data they want. And that secondly, the system will generate an estimate of the SQL script that's required to actually extract the data from the EMR. So that'll be invisible to the user, but that will then be made available to the technical person. And let me explain a little bit how that works in terms of the who and the where of QITE. So you're looking at a straightforward swim lane diagram that shows the process flow of our researcher, our QITE application, and then the IT specialist. And in a nutshell, it's pretty straightforward. Our system provides an interface where the researcher and clinician can actually tell the IT professional what it is they want, so which data elements they want, what cohort of patients they want. The IT specialist can look at what they've requested and then may have a few more questions. And then ultimately, the application then generates this selection script, this SQL script to select the data from the EMR. And the technical person may be able to use it as is, or they may need to refine it. And then they can actually extract the data, give that back to the clinician or researcher, who then will incorporate that into potentially a report or a dashboard or research. Okay, so let's take you through a sort of step-by-step use case. These are sort of the classic steps that someone would follow if they're going to use QITE. And I'll take you through each of these. So starting off with establishing these dictionary elements. Now, before I even get to those, I've sort of got a step 0 here because there are a few base or building blocks that are required in the program that service all of the work that's going to happen within the program. One of them is governance. So in any sort of clinical application, you need to control who can do what, but also who can create these elements, who's allowed to create or define an element, say as heart rate. I know that seems trivial, but there are lots of different definitions of heart rate. It may be heart rate that's captured at certain times and things like that. So the governance controls who can actually set these definitions and create the elements and modify the elements. And then you've got a universal search and dependencies, and I'm going to cover those off a little bit later, but they're just allowing people, anybody, to go into the program and search for elements that they can then reuse for their own purposes. All right, let's jump now back to our step 1. Well, we talked about this concept of a dictionary, and a dictionary has 2 elements, raw elements and computed elements. Now, a raw element is simply a single variable. So you can imagine you want to collect something, one variable for a particular patient, that might be their age. So in this case, you'd have to try and find the patient age. Now, we've got defined a lot of these raw elements already, and more of them are getting added. In this particular case, it's called allergy status. And you'll notice here that it's linked directly to a specific field in the EMR database. So, and that's the allergy.activestatus.cd field. So that would typically be done by a technical person. And but all of this metadata here is filled out by the governance group to say, okay, what is this element? How do we describe it? Are there aliases for it? So has it got acronyms or other names that it's used? What's the aim, the definition? And also validation information if it's a particular element that needs to be defined in a clinical dictionary. You may have that here, and other sorts of metadata as well. And the reason you want all of this is because you want people to be able to find these elements very easily. And when we get to the search screen, then I can show you that you can search for things just using free text, and so people can go, oh, I want this piece of data, and they should be able to find it very quickly and look at it. The other type of element that there is computed elements, and as you can imagine, these are simply elements that are constructed of other raw elements or other computed elements. And I've just demonstrated one here, which is a simple body mass index, BMI, which is the patient weight divided by the square of the patient height. And that's just an example, but as you can imagine, you could create very elaborate computed elements that you might want to capture or collect. Okay, so once these dictionary elements are defined, then a person can come in and they can define their own cohort. Well, what is a cohort? Well, it's part of the dictionary, okay, because it involves a definition. And a cohort itself, I've defined down here, it's basically a set of patients which you want to define by some sort of criteria. So for example, you might want diabetic patients who are over 50 years old, or some other specific logical grouping of these patients. And we provide two methods for you to define your cohort. The first is a sort of tabular method, which has different criteria. You can see here that's just a typical table where you're saying, okay, I'm looking at this person ID. They might have this ID here, and this catalog type code is within these two values, consults or patient care, and this task state, it's overdue or pending, or this encounter status, etc. So this is just to give you an example of the kinds of things that you can put when you define your cohort of patients. You also could define it as a tree in the same way that we had a tree before when we were doing computed elements. We can use the same kind of tree here, and it's just using Boolean logic to define exactly the same thing that we define in this table. It's important also to note that these cohorts that you define can be inherited. So although the first person might want diabetic patients over 50 years old, the next person might want diabetic patients over 50 years old who are on a specific medication, and they define what that medication is. So you could then simply say this cohort here and medication in these particular lists of medications. And this is really handy because it means that you don't have to start from scratch every time you want to define a cohort of patients. And people always want to define a cohort of patients when they want to select data, because they're saying, I want to select certain variables for this cohort of patients. Okay, and that brings us to selecting variables. So it's pretty straightforward now. We've defined our cohort of patients, but what variables do we want to actually collect for that set of patients? And so this just provides you with an easy way of selecting different variables, and we've grouped them into different domains. And those variables might be either raw elements or they might be computed elements. They can be either of those. And remembering that the person, the clinician or the researcher has no idea of the underlying structure of the actual EMR database itself, so they just want to find the variables that are of interest to them, and they'll understand things like, oh, okay, medication administration. Yep, I'll look there for if I want to understand which particular medications a patient's got, or I want to understand particular problems or diagnoses that they might have, or I want their demographic data, for example, around the patient, so age or date of birth or their height, for example. So they can click on those and then select from the list of available computed elements or raw elements over here, or they could just type automatically in here and it will try and find the ones that match your wording. All right, so we've now got our variables that we said we want for the data set. We've got our cohort defined. So this is where we actually have to try and generate this SQL output. And this is what we call a published data set. And as you can see, it's the combination of a cohort of patients and the base data set. Well, the first thing you're going to do is you're going to select your dependencies, you're going to select your base data set, you're going to select your cohort, and that defines what the published data set is. And then the system then is going to work out for you, all right, you've selected all these variables, they're contained in different tables. I'm going to have to work out how the tables all connect together in terms of joins. And then I'm also going to provide you with a set of business rules that potentially affect the SQL itself. And that's because the technical people who work with the EMR database understand that there's a lot of business rules that are associated with the SQL, with the extraction SQL itself. So it may be that the person looking for the data, the researcher or clinician, they actually don't touch this. But the system itself provides it so that when the technical person looks at it, they can add in their own business rules over here and select from the ones that are associated with each of the different tables associated with the variables that have been selected. And then, of course, it generates this SQL that is available for the technical person to then go ahead and perform the extract on the EMR. Now, it's an estimated SQL. The SQL itself is valid, but it may not be optimized. So it may be that the technical person has got to modify this to optimize it, or there are things missing, etc. But the key point is that even for technical staff, and remember, there aren't that many technical staff that really understand a lot of the EMR. They might understand some parts, but not others. So this gives them all of the fields that they need to understand, all of the tables where those fields come from, and the joins that are associated with those. So it gives them a flying head start towards actually producing the final SQL. And that's the purpose of the application. And the last step, of course, is actually using that data. And here, the person who requested the data can go ahead and define the data products that they might want, reports, dashboards, or research area. And once again, what they're doing here is they're really defining the metadata associated with that. So here's a sample dashboard. They're putting in which data sets are getting used, okay, as part of that dashboard, for example. And we also can start to see the data lineage. And I'm going to just explain that in a little bit more detail in a moment. So you're probably asking, well, why would they do that? I mean, why go to the effort of putting in this metadata around this dashboard? But you've got to understand, so with a public healthcare body like Queensland Health, and it would be similar in Indonesia, you would have probably hundreds of hospitals all around your country, as we do around the state of Queensland. And so although you might run a sample dashboard, which was put together by some clinicians in one particular area, which might be related to diabetic patients, then that may be of high interest to other areas, other hospitals as well. And so this allows clinicians to go searching for these and go, oh, okay, there's a dashboard. I understand now these are all of the variables that are collected on that dashboard. Wow, that might be a lot of use for us to use. And so rather than starting from scratch, they might just select this dashboard or make a few small changes and inherit from this dashboard. And as you can start to see, the more elements that are already defined in here and the easier it is for people to find those elements, then the less work that needs to be done. And we're reusing all of this knowledge as it grows and grows. We get more and more knowledge that's built into the application. And I mentioned the universal search. So that's what this is. If you're looking for something related to birth, there might be all sorts of things. There could be, there might be data sets that include the birth date or time of patients. There might be a raw element, which there definitely is. There may be there may be dashboards that are related to the raw element called birth. So this allows anyone to go in and search for any kind of element. They can filter it as they need and try and find elements that they can then go on and use. Secondly, there's also this concept of dependencies. And this is really essential because it's really hard to understand which data you're using in any particular report or dashboard. And so what this does is it provides a full lineage from every single element to all of the other elements. So if one published data set is using a particular cohort, and that's related to particular raw elements and computed elements, then these are all linked together in a chain, and you're able to see those. Now, at the moment, I'm looking at it graphically, but you could also look at it in tabular format, etc. And you can look upstream and downstream. And it also means that if changes are made, we can start to understand what's going to be impacted by those changes. Okay, in terms of evaluation, so we've got two sets of evaluation that are being performed. One's around user acceptance testing, and the second one is around performance. So this will proceed over the coming months. First of all, around SQL generation accuracy, around time savings, so that you can compare how long it takes a person to use the existing process of asking a technician one-on-one and then going through the lengthy process of defining what they want and then ultimately ending up with a SQL and getting the data extract versus using the system as is now. And then data set coverage, which, as you can start to see, that the more the system's used, then the more coverage we get of the EMR in terms of the data that's made available to everybody to use. So this is an ongoing part of the research project and will be published towards the end of the project, I'd say in the next 6 or so months. Future directions, where's all of this going? Well, we'd like to add 2 more components, which will happen, and we've got a grant to do that over the coming 18 months. One is a cohort laboratory. And what this means is that it's actually a really important task to be able to select the right cohorts of patients. And you're probably wondering why, but when anyone wants to do a random controlled trial, or they want to do some sort of specific set of tests, they always need to specify what particular patient group they want to perform those tests on. And you might think that picking those cohorts just with a standard SQL because you want someone over the age of X and that, you know, has a certain height or something like that, that's easy enough. But actually a lot of the data around these cohorts might exist in the unstructured data. So this is around clinical notes. And so we're providing a search facility which you can use the clinical notes to find and to enhance your cohort definition. Because a lot of the data, in order to describe your cohort, may only be contained within the unstructured data. So as an example, you might be searching for patients with a patient history of diabetes, but you don't want them to have diabetes now. Now, to find that, you may need to look in the unstructured data at the patient history. The second aspect we're going to add is around artificial intelligence. As you can imagine, there's a huge amount of work being done around the world in the clinical domain around artificial intelligence. And so, although we've got a completely separate project that's looking at building an artificial intelligence sandpit for the clinical domain, we want to start applying this within the system so that you can build pipelines of data. So rather than just a static data set, you can build a transformed data set, which will then go ahead and be used within AI models, so deep learning and machine learning models. And these will allow you to do prediction work. And that's why we've got an extension here around prediction, or an AI lab. So you can predict things like patient deterioration. You can predict things like whether or not there's going to be readmission or mortality in 30 days, or length of stay, or potentially that a patient might contract sepsis while they're in hospital, etc. So these are all, these 2 particular things that we've talked about are our future additions, and we're looking at putting those in over the coming 18 months. We have a relatively small team. We've got Associate Professor Guido Zuccon, who leads this work. I'm leading the work on the ground down in Queensland Health. Dr. Harry Skells, Monica Nazelli, and another one, Dan Block, who's not on, who hasn't provided a picture, but he's also in the team. And these 3 people especially are doing most of the development work. Okay, I hope I've given you some insights into a piece of applied research that we're putting into Queensland Health, a very large public healthcare provider. And I'm very keen to answer as many questions as I'm able to if you have any on what I've just talked about.
Thank you, Anton. That's very, very interesting work that you are currently doing. So as usual, anyone who wants to ask any question, please raise your hand in the Zoom using the Zoom reaction. And as usual, I will use my privilege as your moderator to ask a question. So I've been wondering, right, when you talk that with this many data, one of the things that we can do with many data is to do prediction, right?
Yes.
I just wonder, will the predicting outcomes impact how or what kind of services provided to a patient? I mean, like, if the system predicts that the patient is going to die anyway, will they then choose not to waste a limited resource, right? And you're going to die anyway, mate. Like, and this one we don't have many. Let's just let him die in peace.
Okay,
That would be nasty, right?
I hope that's not the case, but yeah, no, the idea around the prediction work, and I think there's still quite a ways to go for prediction work to get incorporated into the clinical workflows inside hospitals. So when I was a researcher, you sort of do prediction work and you set up your models and you trial things and test it and you compare it against other people's work and you think, oh wow, you know, I'm doing very well. I think my model's better than a previous model. But as soon as you start working within hospitals and with clinicians, you start to realize that it's one thing to come up with a model that does a prediction, but it's another thing to actually use that model usefully within a clinical environment. And to do that, you have to go through a lot of hoops in order for it to get actually used. It has to go through a pilot, and then typically it might go through a random controlled trial because it's an intervention that actually is going to be used within a clinical environment. So to take your example of predicting death, where would I expect that to go? So if you could predict that this person's may have the chance of a high mortality within 1 month, then it may change things like the discussions that clinician has with those patients. It may change if it's a patient that they weren't expecting to see that, then they may start to try and understand why that prediction was made. And I think this raises a huge area of contention at the moment, which is with a lot of clinicians, and that is that they want to see if you're going to use AI or any sort of machine learning within the clinical environment, clinicians need to understand how and why you came to that prediction. You can't just give them a number and say, we predict this person, has got a high risk for mortality within 30 days. You need to then explain what variables have you used to come to that prediction. So that the clinician can look at that and say, oh, yeah, no, well, that's just wrong. Or, okay, I can go and investigate that. Does that sort of help to answer that?
Yes, thank you. Now we have another question from Dr. Eric Divisono.
Yes, thank you, Pak Jimmy. So good morning, Anton.
Good morning.
Thank you for sharing your research about this. We can call it application of data science, data mining in the field of medical, right?
Yes.
In similar line to what Jimmy just asking, and you inform us at the end of your presentation that the future direction is the prediction or AI. So there's a very wide spectrum to that point, and from the starting point where we just provide the data. I noted you gave example, for example, that the data can be used to calculate, for example, a body mass index. So some kind of a builder like that. Now, what I want to ask you is to what extent you have this kind of builders in the system. Because if you don't have extensive builders, then I think what will happen is that you just convey the data. The input is the data, and the output is the data. But what we want is the input is the data, and the output is the information, something that can be used by the medical practitioners. So to what extent, how extensive is the builders in your system, and maybe you can give us some examples as well. Thank you.
Okay, yeah, and it's a really good that's a really good question, and you know, I've shown you this this starting point because it really was the starting point for Queensland Health, because as you can imagine, it's data in and information out. But if you aren't clear about which data you're looking at, which is what was happening in Queensland Health, if you aren't clear exactly which data elements you're using, then of course you can end up with ridiculous things out the other end. So if, as you can imagine, this was step one, which was actually just a foundation layer to make sure that what data is picked is the correct data. Both it's the correct in terms of it's understood by the clinicians, they know which data they've picked, and also it's correctly selected from the database. Now, when you start moving into AI, we're then talking about a pipeline of data. So if we now are sure about which data we're getting, we then have to potentially transform that data to get it into formats that can be used for artificial intelligence. So there's a whole module there which will require, exactly as you say, a builder that allows you to build off those building blocks and potentially normalize the data, aggregate the data, impute data that's missing because there will be data quality issues, etc. And then the final step then becomes the actual AI models themselves. And this gets to a very, I guess, a very difficult part and of the whole process, which is, can you make deep learning or machine learning models available for non-experts to be able to input their data and come out with sensible predictions? And we don't really have an answer to that yet. That's definitely a research area. And for future research, what we will do is we will build with computer scientists, we will build actual predictive models in certain areas for certain tasks. And we can test and evaluate those, but then we will also see whether or not we can make those available for clinicians to use. For example, if they see insights where they think, oh, I think that we need this extra data here is a new feature that will provide additional information for that artificial intelligence method, and we'll see whether or not they can use it successfully to improve the models or not. And that, at this point in time, is an unknown. We don't know whether or not that's possible. It's if you look in the literature, it's very hard to find anything that currently allows you to do that kind of thing. I hope that's answered your question.
Yes. Okay.
Okay, thank you.
Thank you.
Thank you. One more last question for me, a bit technical. Have you considered data warehouse on your approach, Anton, or is it already a data warehouse in the sense that it's working with a time series of snapshots instead of working with the transactional data?
Yes, correct. Yeah, it's already in a data warehouse, and it gets updated, I think, every 3 minutes.
Really?
Yeah. It gets.
That's crazy.
Yeah, there's multiple mirrors that are made of the database for different purposes. So yes, there's multiple. That technology is already in use, and
okay.
Yeah.
All right. That's fantastic. So if there's no more question, I would like to wrap up what Anton just spoke about his work. So here, Anton mentioned that data collection in Queensland Health has been really, really amazing. They collect a lot of data, a lot, and they are now trying to figure out how they can make the best of the data that they already collected. Like Dr. Eric mentioned, it's important if we can somehow convert the data into a useful information, even for the doctors. And what Anton doing is just that. He's trying to help the specialists, the doctors, to get the best of what they already have in the data collections. And that's not easy because the data is very diverse. It has a lot of data, and some of them are unstructured, and that's the challenges that Anton is currently working on, and that's really, really good, Anton. I hope somehow in the future that can be applied to everyone in the world. I mean, like COVID, I guess the COVID is become the global problem. If one discovery can help other people in other world, that will be great.
Thank you.
Fantastic. Thank you very much. So let's give Anton a round of applause. And I give back to Yemima.